This equation can be used to find H, the number of hours it will take Flo and Brian to mow their lawn. Okay? There's two different ways you could have done this. You could have obviously just plugged in numbers until you found the number that made it equal 1, or you could have solved the equation. First, I'll quickly solve the equation just to remind you how it's done, and then we'll check our answer by checking it. We have H over 3 plus H over 6 equals 1. And the question wants us to figure out how many hours. So the question wants to know, what does H equal? No, you only cross multiply when the fractions are set equal to each other. In this one, they want you to do what to the fractions? Add them. Well, to be able to add fractions, they have to have what? Do they have a common denominator? No, but couldn't we easily make 3 become a 6 by just multiplying it by 2? But then what do you also have to multiply its numerator by 2? So now, the common denominator is now 6. And on the top, you have 2 times H, which is 2H, plus 1H. And so what does the numerator become? 3H. And now to solve for H, what would you do to both sides? Multiply by 6. Those cancel each other out, and you're left with 3H equals 6. And now to solve for H, what would you do to both sides? Divide by 3, and H equals 2. Now, even if you did not know how to add those and solve for H, you could have just plugged in your answer choices, okay? Starting with A. Please pay attention. If you plug in A, which is 6, right here and right here, what's 6 over 3? What's 6 over 6? Is 2 plus 1 equal to 1? No, so A does not work. Then you would have tried B by plugging in 3 into each H place. What's 3 over 3? What's 3 over 6? What's 1 plus 1 half? 1 and a half, which is not the same thing as 1, right? So B didn't work. Then you would plug in C, 2 hours, into both H's. What's 2 over 3? 2/3, or 0.67. What's 2 over 6? 1/3. Is 2/3 plus 1/3 equal to 1? Yes. So that's how the second way you could have done it. Any questions? All right, number 11. A ferry boat carries passengers back and forth between two communities on Peachville River. It takes 30 minutes longer for the ferry to make the trip upstream than downstream. The ferry's average speed in still water is 15 miles per hour, and the river's current is usually 5 miles per hour. This equation can be used to determine how many miles apart the two communities are. Now, they already gave you the equation, right? So really all of this information is not really necessary, okay? Because you already have the equation. Does that make sense? You would only really need to know all that if you were trying to create the equation yourself, but you're not. They gave it to you. What you could do, though, to start is simplify the equation. Like instead of writing m over 15 minus 5, couldn't I just write m over 10? And instead of m over 15 plus 5, couldn't I just write m over 20? And then don't forget, that one also adds 0.5 to the end of it. Now that the equation is simplified, now I'll just start plugging in my choices, starting with A. If I plug in 0.5 right here and right here, what is 0.5 divided by 10? Please use your calculator. 0.5 divided by 10. No, 0.5 divided by 10. 0.05. Now plug in 0.5 over here. What's 0.5 divided by 20 plus 0.5? 0.525. Are those numbers equal to each other? No, they are not, so A's could not work. Then you would have tried B. You would have plugged in 5. What's 5 over 10? 0.5 or 1/2. What's 5 over 20? Plus 0.5? 0.75. Do those numbers equal each other? No, so B is not right. Then you would have tried C, 10. What's 10 divided by 10? What's 10 divided by 20? And what's 1/2 plus 1/2? 1. Those make a true statement, so 10 miles is the correct answer because it makes the equation equal. Any questions about that one? Number 12. For what values of x is the inequality 2 over 3 plus x over 3 greater than 1? What are they wanting you to do with those fractions? What sign is between them? Okay, so add them. To add fractions, you have to have a, and they do. So the common denominator is 3. You don't have to do anything. When you add the numerators, what do you get? 2 plus x is 3. We don't know what x is yet. That's what we're trying to figure out. So, can you really add 2 and x together? So you just leave it 2 plus x. And then don't forget, is greater than 1. Now to solve for x, what would we do? We're trying to get x by itself. So what would we do first? Multiply by 3 first on both sides. And we do that because it's currently divided by 3, and so the inverse operation is to multiply by 3 to cancel those. Now on the left side, you're left with 2 plus x. On the right side, 1 times 3, which is 3. Now to solve for x, what do you do on both sides? Subtract 2. And so x is greater than 1, which is choice B. Okay, even if you have a hard time doing what we just did, you can still plug in choices. However, it's a little different because choice A says x is less than 1. Well, what is the first whole number less than 1? 0. So if you plug in 0 right here, what's 2/3 plus 0 over 3? Still 2/3. Is 2/3 greater than 1? No, so it doesn't work. But if you plug in choice B, a number greater than 1, so like 2, is 2/3 plus 2/3 greater than 1? Yes, because 0.67 plus 0.67 would be above 1, right? So that's another way of doing it. Okay, next page. Look at the steps used when solving 3 parentheses x minus 2 parentheses equals 3 for x. The first thing they do is just write the original equation. They just rewrite it. Well, if you were looking at a problem like this and asked to solve, what would you do first? Right, and isn't that what they did? 3 times x minus 2 became 3x minus 6. And they even wrote over here what they did, distribute. Then, if you're now looking at a problem like this, what would you do next? You're right, you would add this 6 to cancel it here and add it over here. And wasn't that what they did? They added 6 on both sides. What property is that called? In that inverse operations? Because think about it. They're trying to move the 6. Well, to move the 6 to this side, they have to add 6, which is inverse operations. Then, how all of a sudden did that line become that line? They combined. The negative 6 plus 6 combined to a 0, so they just didn't write it. And the 3 plus 6 became a 9. They combined like terms. And that happened in step 2, so step 2 is the answer. Okay, number 15. 2 lines are graphed on this coordinate plane. Which point appears to be a solution of the equations of both lines? 3, 1. The solution is where they intersect. And they intersect at over 3 up 1, so D. That one's pretty easy. Okay, number 16. Based on the tables, at what point did the lines y equals negative x plus 5 and y equals 2x minus 1 intersect? 2, 3. How do you know that? Correct. That is the common coordinate for both tables. They both have that point, so that's where the lines intersect. And if you weren't sure, you could have gone to your graphing calculator and graphed both of those and saw that they crossed at over 2 up 3. All right, number 17. Shh, focus. Look at the table of values for the two linear functions f of x and g of x. What is the solution to f of x equals g of x? So basically it's asking where are they going to intersect if graph. 3, -2. Because isn't that the point they have in common? That's their solution. That's where they would intersect. But you can't actually graph them this time because they didn't give you the equations. Okay, next page. Pay attention. Which ordered pair is a solution of 3y plus 2 equals 2x minus 5? Okay, well, did anybody try this one? Okay, what'd you get, Austin? C is correct. Okay, watch. It's very easy. Just watch. Once I explain it, you'll be like, oh, that's easy. They've given us 4 ordered pairs. Well, in each of these ordered pairs, the first number is the x and the second number is the y. So I'm just going to go through with each choice, plugging them in where they would go. -5 would go in for the x, 2 would go in for the y. What's 3 times 2 plus 2? What's 3 times 2? 6, and 6 plus 2 is 8. Over here, you need the x value, though, -5. What's 2 times -5? What's -10 minus 5? Is 8 equal to -15? No, so A is not right. Then you would go to choice B. You would plug in 0 for the x and -5 for the y. What's 3 times -5? Plus 2. And what's 2 times 0? Minus 5? Is that a true statement? No. -13 does not equal -5. So B doesn't work. Then you would try C, where x is 5, y is 1. 3 times 1 is plus 2. And over here, 2 times 5 is minus 5. Is that a true statement? Yes, 5 equals 5, so that's why C is the answer. Now don't you see how easy that is? Okay, number 19. A manager is comparing the cost of buying baseball caps from 2 different companies. Company X charges a $50 fee plus $7 per baseball cap, while Company Y charges a $30 fee plus $9 per baseball cap. Can you create equations for each of those scenarios? What would the equation be for Company X? 7x, or 7c if you wanted to use C for cap, plus the $50 fee. $7 per cap plus $50 fee. What would the equation be for Company Y? Now, they want to know for what number of baseball caps will the cost be the same at both companies. So what could you do? You could. That's something nobody said all day. You could graph it and see where they intersect. Or you could plug in each of these numbers for x. Or, think about it. The same means equal. We could just set them equal to 0. Set them equal to each other. And just solve. To solve, what would you do first? Okay, you could minus 50, cancel it over here, minus it over there. And now you have 7x equals 9x minus 20, and then what would you do? Not yet. First, we'll have to just do that. First, you would now have to minus that 9x to join the 7x, correct? And you would get -2x equals -20, and then what's the last step? Divide by -2, divide by -2, so x equals 10. That's one way to do it, is just set your equations equal, because you want to know when the cost will be the same, which means equal. Or, if you don't know how to do that, you could graph them and see where they intersect. Or, once you have your 2 equations, you could just start by plugging them in. Like if I plug in 10 here, 7 times 10 is, plus 50 is, and then if I plug in 10 here, 9 times 10 is, plus 30 is, so that makes the cost the same at 10 caps. So any way you want to do it. Any questions? Okay, number 20. A shop sells 1-pound bags of peanuts for $2 and 3-pound bags of peanuts for $5. If 9 bags are purchased for a total cost of $36, how many 3-pound bags were purchased? So first you need to think about what the question's asking you. What are they asking you to figure out? How many 3-pound bags were purchased, right? So doesn't that mean each of these answers down here represents 3-pound bags? Okay, so above it I'm going to write 3 pound because all of these are for 3-pound bags. Well, if 3-pound bags, or if, how much are 3-pound bags? $5. So if you purchase 3, you're paying how much money for those 3? If you purchase 6, you're paying how much money? If you're paying, or if you're buying 9 of those, how much are you paying? And if you buy 18 3-pound bags, you would pay, no, what's 18 times 5? 50 and 40 is 90. Okay, I know, I heard you. Okay, well, let's now use our common sense. Could she have really purchased 9 or 18 3-pound bags? Because she only spent how much money total? She only spent this much, and both of those go over that. So there's no way she could have purchased that many. Well, then you need to consider that if she purchased that many 3-pound bags, that would be $15, but her total was 36, so that would leave how much money that went to the 1-pound bags? Oh, I just wrote it, 21. Well, can you really spend $21 on $2 bags evenly? No, so that wouldn't work. It would have to be B. Now, I know you're not going to do it this way. I just want to show you a quick reminder of the way we would have solved this back when we did Unit 2. We would have set up a system of equations. We would have called the 1-pound bags X and the 3-pound bags Y. And we know that she bought, between the two different types, she bought 9 bags. We also know that the 1-pound bags are $2 and the 3-pound bags are $5, and we know when money is involved, she spent $36. At that point to solve this, we did elimination, which meant we multiplied this top equation by a -2. Now the reason I multiply it by a -2, this becomes a -18 when you multiply by -2, is so those will cancel each other out. And then that becomes 3y, that becomes 18, and then when you divide by 3 on both sides, you get y equals 6. Okay? Y'all actually knew how to do that at one point this year on the Unit 2 test. Okay? That's called elimination. We also graphed to see where they intersected. And then I can't remember if we did substitution. I don't think we did ever do substitution. Okay, 21. Which graph represents a system of linear equations that has multiple common coordinate pairs? B. Okay, let me rephrase this. Which graph represents a system of linear equations that has multiple points in common? Okay, think about it. A and C, their graphs only have how many points in common? 1. They only cross 1 time, so that's 1 point in common, and that's 1 point in common. D's graphs have how many points in common?
0.
None, because they're parallel, they don't ever intersect. So they have none of the same points. But B is a line graphed on top of another line, so don't they have lots and lots of points in common? Every point one has, doesn't the other one have? So does that make sense now? Okay, number 22. Focus, we are almost done. Which function represents the sequence? Okay, what did y'all get for this one? Okay, anybody get anything different? Okay, anything different? The correct answer is B. Okay, let's talk about why. Back when I taught you about sequences, this is what's known as an arithmetic sequence. The reason it's arithmetic is because you can get from one number in the sequence to the next by doing what? Adding 7. Okay, if you can add or subtract by the same number every time, that's known as an arithmetic sequence. Now, we learned a formula called the explicit formula. It's A sub n equals D times n. Oh my gosh. Sorry.